Hey everyone, and welcome to Maths with Magda. Today we are starting one of the most important topics in Living Cert higher level maths, and that's the differentiation. So what you need to know that the derivative means the slope. But hold on, you already know the slope from the junior set, right? So the slope is just, if I have 2 points, to find the slope, I'm using the formula y2 minus y1 over x2 minus x1, or I could use another one, rise over run, or if I have an equation of this, the slope is just the number in front of your x. So that's my slope over here. But you can see that all these formulas are for just one type of function, and that's the linear function. So if I draw the graph of the linear function, the slope is a constant at any point on that line. And now, if I'm going to take the graph of the cubic function here, you can see that over here the slope will be negative. Down here slope is positive because my function is increasing. Okay, and then finally at my maximum or minimum, the slope will be equal to 0 because there is no steepness of that tangent at these points. So the slope means it's different for different parts of that graph. So what we need to know is that derivative means the slope, and then the differentiation is the way of finding that slope. Now, the symbols, guys. So remember that if your function is called y, then the symbol for the derivative of that will be dy over dx. And if my function is called f of x, then the best way to express the derivative of that function will be f dash of x. So now let's move on to the rules, how to find the derivative of different functions, and then we move on to a first principle. So guys, the rules. How do we find the slope for any function? Well, there are rules that are called the general, product, quotient, and finally the chain rule. Let's start with the general rule. So to find the slope of the tangent for the functions like in the form x to the power of n, we basically move the power to the front and then we reduce the power by 1. So let's practice this rule now. Over here, if my function is y equals x to the power 4 plus 7, so dy over dx is just 4x, and then I'm reducing the power by 1, so it's 3, and then the derivative of any constant is just 0, so I don't write the derivative of 7. For the next one, the same thing, and then if you have already something in front of your x, you're just multiplying the power by the coefficient, so that gives you 14x to the power of 6 plus 6x to the power of 1. Next one over here. So now if I have cubic root of x, I don't know how I differentiate something like this unless I'm going to change that using the rules of indices into the form x to the power of 1/3. Then dy over dx is just simply 1/3 x, and when I reduce 1/3 by 1 is just minus 2/3. Next one, again, I need to do something with this before I differentiate that. So that will give me x cubed plus 7x. Remember, fraction means negative power. So it's minus 2 plus x minus 2. And now I differentiate each of these terms separately. So that will be dy over dx. And then I get 3x squared minus 14x to the power of minus 3, and then plus 1. And that's my derivative. So this is all when it comes to a general rule. So next one is the product rule. Remember, guys, that the product rule means the multiplication. So if your function is expressed as a product or multiplication of two mini functions, this is the rule that you should apply to find the derivative. So you can see over here I have a multiplication of two brackets. Let's call one of the brackets u, the other will be my v, and now I write them separately, u, v. So my u will be 3x plus 1. My v is just 5x plus 2. Let's differentiate them separately. So now derivative of my u will be called du over dx, and it's just 3. Then for this one, I get dv over dx, and the derivative of that is just 5. Now, how will I work with this now? You have the formula in your log tables, but it's actually very simple to memorize. The only thing that we need to do over here is cross multiply and add these two. So I go back now to my y, and then derivative of dy over dx is simply 3x plus 1. That will be my first multiplication, and then plus 3 bracket 5x plus 2. And then, of course, we multiply out the brackets and adding like terms. As you can see, I don't have enough space here, so I'm going to leave it like that. For the next one, the same thing. I'm going to call the u and v first. So my u will be the first bracket, and that is 1 minus x squared. The second is my v, so x squared plus 5x plus 3. Now let's differentiate that again. So du over dx, the derivative of this will be just minus 2x. Remember, derivative of 1 is just 0. And then for my dv over dx, I have 2x plus 5. And then again, I do the cross multiply and adding them to. So I go back to the derivative of my main function dy dx, and then what I get is 1 minus x squared by 2x plus 5, and then my other one will be minus, this time minus 2x bracket x squared plus 5x plus 3. And this is how you get the derivative using the product rule. So now let's move on to another type of function. Okay, so you can see that this one is expressed as a fraction. So if you have one function over another function, the best way to find the derivative is by using the quotient rule. Okay, and now how does it work? The same way like with the product rule. So I'm going to call it u, and my u is 3x plus 1, and then my v will be equal to 7x minus 2. I need to differentiate that separately. So du over dx, derivative of that is just 3, and then dv over dx, derivative is just 7. So my dy over dx is equal to v, which is this, multiplied by the derivative of u. So I'm going to keep it like that, 7x minus 2, and then minus the other one, u by this. So I'm going to start with the 7 and then 3x plus 1 all over 7x minus 2 to be squared. So now what do I have to do with this? Now, I simplify the top, but my bottom stays with the power. I do not expand the bottom. So when I do that, I get the following: 21x minus 6 minus 21x, and then minus 7 all over 7x minus 2 to be squared. Now you can see that the x's will cancel, and I will get then minus 13 over 7x minus 2 to the power of 2. And this is the way how you get the formula for the slope of that function over there in the form 3x plus 1 over 7x minus 2. So what next? To get the next rule, I'm going to do a quick introduction to functions that are called the composite functions, okay? Because the next rule is called the chain rule, and that's the one when sometimes is called inside-outside rule. Okay, so if you have functions like this and you compose them like that, instead of that, you can write them like f of g of x. So you can see that you have one function that is inside and the other that is outside. And then what we do, let's compose some of them. So for the one that I have over here, instead of that dot or circle, let's call it this way, it's it's f after g, and then you have x, and then what we do, we sub in entire g into f. So instead of x, I put 8x plus 3 to the power of 3. And then here you have a two function. The outside is my power. So this is my out. And the one that I have in here, it's my inside function. The next one, again, I do exactly the same thing. So it's g inside of f. So I take the x squared and sub it in, replace the x with that. So what I should get over here is sine of x squared. This time x squared is my inside, and then sine is the one that is outside. Next function, let's move on over here. Now I sub in an entire function sine of x into function f. So that will give me the following. Okay, I get sine x to the power of 2, or something like this also can be written in the form sine square x. And now your outside here is power, so that's your outside, and you can see that inside will be your just function sine. So this one is in side. Okay, next one, this time we're going to do the e to the power of x and sine of x. So if you look at this one here, again, I sub in sine for x, and then I get a function that's e sine of x, and now the inside is my sine of x, and outside is my e, outside, sorry, it's my e. And then for the next one, let's move on to a chain rule. Okay, so when I do the chain rule, as I said, the chain rule is inside outside rule. So anytime when I differentiate the composite function, I differentiate outside first, and then I multiply that by the derivative of inside. So that's my inside derivative, that's my outside derivative. So when you look at your function like this, what I see over here is that I have two functions here. One is something to the power of 7, and then my other one is 8x plus 3. So you can see that this one is my out, this one is my inside function, and then I plug in this inside of that. So what about the derivative of something like this? Okay, so I take the dy over dx, and then I differentiate the power. So I bring the power to the front, all the inside stays the same, so it will be 8x plus 3, and then I reduce the power by 1, so that gives me 6, and then I multiply that by the derivative of inside, which is just 8. And then of course I could simplify more, but in this video it's all about the understanding the chain rule. Next one, the same thing. You can see this is your out, this is your inside. So let's start with differentiating your out first. So dy over dx is just simply 2 bracket 7x squared plus 3x, and then I multiply that to the power of 1, and then I multiply that by the derivative of inside, and that will be just 14x plus 3. Then the next one, guys. So when I see something like this, okay, then I can see two functions here. One is the sine and another one is 10x. Now, so how will I get what is inside and what is outside here, okay? Now, if you don't see it, what you could do, you can go to your log tables, and you can see that in the log tables, the formula for the derivative, you have sine of x there, okay? So you can see that the basic function, that basic trigonometric function was replaced with the something new, and that new is your 10x. So what is new is your inside, and what is old is your outside. So the first thing that we do, we differentiate the outside, and the derivative of sine is just cos. So we go cos of 10x. Again, remember, inside stays the same, and then I go inside, and the derivative of 10x will be just 10, and always put the constant at the front because it looks nicer this way. For the next one, this one is slightly different because you can see that you have a power and sine of x, and that could be written in the following way: sine x to the power of 4. And now the sine of x is in your log tables, okay? So nothing has changed with that. So the power is outside, and the sine of x will be your inside. So when I do that, again, it's 4 sine, and I replace the power, reduce the power by 1. So it's 3x, and then I multiply that by the derivative of outside, of inside, which is just cos of x. Now, here it's a different one. Remember that the derivative of in the log tables, you have a function y over is equal to sine of x. So again, the x is replaced by the x squared. So this is your new. So that will be your inside. And then when we differentiate that, we do dy over dx. And then I differentiate my sine. Derivative of sine is just cos. Inside stays the same, and then when I differentiate my inside x squared, the derivative is just 2x. Okay, let's move on with more examples. So now we have exponential functions, and now if you go to your log tables, okay, the formula that you have there is that if your function is in the form e to the power of x, then the derivative of that is just e to the power of x. So it's the same function. Now, but here I have something different. I have e to the power of 2x. So my new function is 2x. So this will be my inside, and my e is outside. Let's differentiate that using the chain rule again. So I derivative of outside of e to the power of something is e to the same power, and then derivative of 2x is just 2. And I multiply it like this. The same with the second one. So dy over dx, and the derivative of that is 8, e to the power of 8x. Next one here. So now it's getting more complicated. I have e and sine of x, but it works the same way, guys. You can see that the x was replaced by the trigonometric function, but it's still my inside. So when I differentiate that, I get the following: dy dx is equal to e of something is e to the same power. So it's e to the power of sine of x. And then the derivative of sine of x is just cos x. Next one inside is x squared plus 1. So when I differentiate that, again, I get the following: e to the power of x squared plus 1, and then by the derivative of inside, which is just 2x. Next one, guys, so if you look at the e to the power of cos of x, the inside is cos of x, outside is e, so dy over dx, again e to the power of cos of x, and then derivative of cos of x in your log tables is just minus sine of x. Now, what is next? We move on to another type of the function. So now I have a square root. Okay, so the square root doesn't help me, doesn't tell me anything how to differentiate something like this, but I know that the square root is the same as power of a half, and then you can clearly see that again I could use the chain rule. My outside is a power, inside is x squared plus 5x. So when I differentiate that, I will get the following: a half, and then x squared plus 5x to the power of minus a half, and then multiply that by the derivative of inside, which is just 2x plus 5. Do I leave it like this? Absolutely not, because we're using the indices to differentiate something, but at the end we want to keep it without a fractional and negative power. So for this one, what we do is we're gonna get the following. Now, anything that is with the minus must be under the division line. So that means that this is with the minus, so that goes over here. Okay, and then half gives me the square root. This is the positive power, so that must be 2x plus 5 at the top. And now the 2 is under the division line, so it also must be over here. And that's your final derivative of that function. Now, if you look at something like this, we could probably use the quotient rule, but it's a bit too long. So instead of that, I'm going to use again rules of indices, and if I have a number at on the top, then I can write it like this: 1 bracket x squared minus 3x plus, let's put the 1 over there, 1 to the power of minus 7. That's very important to remember that I get rid of the fraction, so my power becomes negative, and this way I could avoid the quotient rule and differentiate that using the chain rule. So look what I'm doing. I bring the power to the front and multiply by 1, so it's minus 7, and then x squared minus 3x plus 1, and then reduce the minus 7 by 1, so that will give me minus 8, and then I multiply that by the derivative of inside, which is just 2x minus 3. And then again, what do? We change the minus into a fraction, and then this will be at the bottom, plus 1 to the power of 8, and then anything that it's not with the negative power will be on the top of that fraction. So it's 2x minus 3. Now, the next one is the one. The next one is the one where, again, you have a fraction. So what we're going to do over here is I'm going to change that. So this time I have a fraction and a square root, so it will be a negative and fractional power, so that will give me x cubed plus 2x to the power of minus a half, and then I multiply out this, so I get the again chain rule here. Minus a half times 5 will be just minus 5 over 2, x cubed plus 2x to the power of minus 1, so that will give me minus 3 halves, and then I multiply that by the derivative of inside, which is just 3x squared plus 2. What do I have to do? Again, bracket, remember, not bracket, the division line. What I have with the minus will be at the bottom, so x cubed plus 2x. Now the 3 halves, it will be just the square root of that to the power of 3. and then the 2 is under division line, so I put the 2 over here, minus 5, and then 3x squared plus 2. There you go. Then next one, here we have 10 over x, sine x to the power of 3 again. Let's use the rules of exponent, so it's 10, and then I have sine of x to the power of minus 3, chain rule here. So my outside is minus 3, my inside is sine, so I get minus 30 sine of x to the power of minus 4, and then I multiply it by the derivative of inside, which is just cos of x. Again, we go back to a fractional form, so sine x to the power of 4 is at the bottom, and then the top part will be 30 by cos of x. And that's how you get that derivative. Now, for this one here, okay, you need to remember that it's not the sine to the power of minus 1. It's actually the one, it's called the sine inverse. I'm not sure about the formula for this one, so I skip this one for now and come back to you with in separate videos. Over here we have a logarithm, so let's focus on that. Now, the logarithms, if you go to your log tables, the derivative of natural log of x is just 1 over x. And now what I have to do over here, again, you can see that the x in the first one is replaced with the x squared. So that will be another chain rule, then dy over dx. The new thing is my inside, and then ln is my outside. So when I differentiate outside, I get 1 over x squared, and then multiply it by the derivative of inside, which is just 2x. Now we could simplify, as the x with the power will be gone, and then I get 2 over x. Now, for the next one, you can see that I have natural log of something like this. So it looks like I need to use the chain rule and quotient rule, which is way too much for me and for anyone who does the leaving cert exam. So let's try to use some rules of logarithms here to make it to simplify this question. So remember that if I have something like this, natural log of x over y, that can be changed into ln of x minus natural log of y. And that's what I want to do over here. I want to break the division into subtraction of the two logs. So I get ln 3 minus x squared, and then minus ln x minus 2. Now looks much simpler now, so I can simplify it separately. So dy over dx is equal to, I differentiate that first, so ln is my out, inside is 3 minus x squared, so it's 1 over 3 minus x squared, times derivative of inside is minus 2 x, and then I differentiate my other one, make sure that that's with the brackets, and then that will be 1 over x minus 2, and the derivative of inside will be just 1. And then, of course, you could put that over here. Okay, now next one, let's have a look what we have over here. So now I have multiplication. The multiplication with the log also can be replace it with the addition. So anytime when my function is in the form ln of x by y, okay, and I don't want to use the chain and product rule at the same time, I could break the multiplication as a sum of the two logs with the same base. So that's what I'm going to do over here, and then I get natural log of x plus 2 plus natural log of x minus 1. Let's differentiate that. So dy over dx is just 1 over x plus 2 and then by 1 and plus 1 over x minus 1 by 2, which gives you the same thing. So you can see that knowing all the rules of logs and exponents can simplify something like this a lot. Next one, again, what I'm going to do over here, I'm going to use the superpower and use the rules of logs. So first of all, I get rid of the a multiplication, so I can write that in the form of y equals 2 natural log of 3x squared plus 1 to the power of 3 plus ln of 2x plus 5. And then what we have to do over here, I can differentiate it now, or I can move the 3 the power to the front. So then I get something like this plus ln 2x plus 5, and now derivative of this function will be just 3 bracket 1 over 3x squared plus 1, and then derivative of inside is just 6x plus 1 over 2x plus 5, and then derivative of inside is just 2. Now the numbers like this going to the top, so I will get 18x over 3x squared plus 1, and then plus 2 over 2x plus 5. And let's leave it like at that. So next one, what we have is the worksheet. So we're not going to do it right now. Remember, guys, that the derivative means slope, and to find the slope, we could use different rules like general, quotient, product, and the chain rule. And if you know the chain rule, you know how to get derivative of any function. So thank you for watching, and stay for more. Next video, we're going to do the first principle. So the definition of the derivative and proof. Thank you. Bye. Finally, we look at the differentiation of inverse trigonometric functions. So remember, when you see something like this, it's not sine to the power of -1. The whole thing that we have over here is called the sine inverse, and that's the function. So if you go to your log tables, there you go. This is the formula that we should use. But you can see that it's slightly different than what we have over here. First of all, we don't have a fraction, but it's easy to make it, because the only thing that you need to do is put it over 1. This way my a is 1, and this is my x, which is great. You can see that the x is different. It's replaced by the 2x, so that means that again I will have to use the chain rule here. So I'm start with my outside, and the outside is of course the sine inverse, so that's my out, and then the 2x is new thing, so this is my inside. Let's differentiate that, follow the rule. So the derivative of that will be dy over dx is equal to 1 over my a is 1, so it's square root of 1 to be squared, so it's 1 minus my x is 2x to be squared, and then we multiply that by the derivative of inside, which is just 2. And then when we multiply that out, we get the following. 2 will be on the top, and then square root of 1 minus 4x squared at the bottom. Now let's have a look at the next example, very much the same thing. So again, what I have over here is sine inverse. At this time I have x squared plus 3. Again, I need to change it to a fraction, so I put that over 1. This is my a, that's my x, so you can see we have a new function, and that will be my inside. So again, dy over dx, I go like this, 1 over, and then I will have square root of 1 minus, or plus, it's minus, x squared plus 3 to the power of 2, and then I multiply that by the derivative of my inside, which is just 2x, and that will be on the top as well. So what else do we have here? If I look to the next example, okay, now I have something like this. It's cos inverse with the x squared. So what I do again, probably have to put that over 1. And then let's have a look at the formula for cos inverse. That is the same as the sine, but with the minus. Okay, I go back here, then again, I start with the differentiating my outside. So the derivative of that is just dx, and that will be minus 1 over square root of, this is my a, that's my x. So it's a 1 minus x squared to the power of 2, and then multiplied by the derivative of inside, which is just 2x. Next one, guys, so this is the last one here, but this time it's something different. You can see that your x is at the bottom, and the formula that you have in your log tables is for something like this: sine inverse of x over a. So your x must be on the top of the fraction, and to do that, again, we rewrite that using the rules of indices. So I change that to 2 by x to the power of minus 1. And again, I put that over 1. This way, my a is 1 and my x will be 2x to the power of minus 1. Let's differentiate that here. So it's dy over dx. Derivative of outside will be 1 over square root of 1 minus 2x to the power of minus 1, and then to the power of 2. And then when I differentiate my inside, I will get minus 2x to the power of, reduce the power by 1, so it's minus 2 again. Of course, we could tidy up this now, so I get rid of the negative power, and when I do that, I get 1 over square root of 1 minus the minus, and I square it, so that will be 4 over x to the power of minus 2, and that will be x squared. Okay, so you can see that that becomes a fraction, and then I multiply that by minus 2 over x to the power of 2 at the end, and that is my final answer. So please save this video. It's a good basic concept of the differentiation with all the rules, and then follow for more Leaving Cert preparation with Maths with Magda. Thank you for watching. Bye.